everyone, this is Wade Hood in Canadian High School, and this is a video on using a vernier caliper to measure to the nearest 1/10 of a millimeter. Why would you do this? Well, in real life, like in cars and stuff, they measure like valves and nuts and bolts and stuff. The other day I was working on my car and I'm like, hey, I wonder what size this is, and I can take every socket and stick it on the bolt, but I can just stick this on the bolt. And since I'm pretty good with millimeters and centimeters, I can see if this was if it's 22.5, I'm going to use a 23 millimeter bolt. So, well, in class we are measuring some metal cylinders to find their density. This is our first lab on measurement and density of water, stuff about significant figures and stuff like that. So we're going to measure this dime because it's a pretty standard device. Now some of the dimes have their edges worn off, so we'll have a little bit of variability in the diameter of a dime, but I'm going to stick it on here and we're going to measure it, and we're going to see how to measure it. So this scale right here, the outside scale, the inside scale would be to measure the inside of like a cylinder for a car or something, but we're measuring the outside diameter of this. So do you see how it goes from 0 to 20? And we're almost to the 18, which means we're 17 point something. Now the vernier scale up here is going to line up. Do you see how let me get it focused better. There we go. Do you see how the 0 does not line up, the 1 does not line up, the 0.2 does not line up, but right here, let me get it focused better. Do you see that the 0.7 and the 0.8 and the 0.9 kind of line up? I'm looking like, yeah, looky there. It looks to me like the 0.9 lines up. So this number is almost to the 18. It's 17.9 millimeters. And I'll write that down in a moment. But this measurement was 17.9 millimeters, and I've taken pictures of some other ones, so I'll do those measurements in a moment. And then you're going to measure some of these metal cylinders, and you're going to measure, which they're all standard metal cylinders, except their diameters and heights are pretty close. There may be a small variation in them, but they're pretty identical. The volume's the same, but the masses are way different. And some of you know this is probably a light metal, density of about 2.7. You'll probably find out what that is from looking on the periodic table of elements to find the densities. These are heavier. Oh gee, these look similar, but man, this looks like an element, but this looks like it's not an element. It's an alloy. So you're not going to find it on the periodic table, and it would not have a good percent error. So we'll be finding the densities and the percent errors of these metals. And we're also using, the other video was on the burette, how to read the burette accurately to find the density of water is close to 0.998. But this is how to read the vernier scale, and I would show this one, but my students are going to be doing this, so I don't want to give them the answers, but we'll just show them how to measure with the caliper. Okay, thanks.